Hi there, this is Alan with the Chapter 5 homework review. Please obviously make sure that you hold off on viewing this if you haven't already given the problems a try, okay? I'm going to try to get through all of the assigned problems today. And you should see a worksheet up here on my upper right, which gives you all of the work, and we'll do them as we go together here. Okay, first of all, I asked you to try problem number 1. It says, explain how bonds might carry a conversion option or a call option, and with the presence of either of those options on a standard bond, how they would affect the interest rate that the bond issuer has to offer. Okay, I'll be the issuer, you be the bond investor, the bond holder. Okay, if you have a conversion option, okay, now this is a power that you have. You have the right at some point in the future, depending on certain conditions, to convert your bond over into the stock of the company. So that's a power you have, and that means if you have a conversion option, you have something of value, that means somehow, some way you're going to have to pay for it, and that will tend to lower the interest rate. Okay? You can't have it both ways, in other words. Okay. So I have to give that up to you, therefore I'm going to give you a lower interest rate as a result. A call option, on the other hand, places a power with me. That's a power I now have as the issuer, and that means that you're going to make me pay for it by offering you a higher interest rate than would otherwise govern. I have to incentivize you with a higher rate. Again, all things equal. I hope that's clear, okay? Problem number, I didn't make you do 2 or 3, I asked you to do problem number 4. Let's see what we've got. Why is the yield to maturity considered to be a better measure of the return to the bond investor? Okay, the YTM is superior because it gives consideration not only to the interest you'll receive, okay, but also whether you get to buy the bond at a discount, that's a benefit to you, or have to pay a premium. That's a negative aspect to you. That's going to cut into your earnings, okay? So generally speaking, the YTM will be lower than the face rate if you have to pay a premium. It will be higher than the face rate if you get to buy the bond at a discount. Okay, so because it considers all financial aspects, bond investors do consider it to be a superior measurement of your overall yield on a bond. Okay, problem number 6. Okay, study all these carefully for me, because if I mention something in homework, if I give an assignment, that's something we tend to see again. Okay, excuse me. Problem number 6. Your GE bonds have a face rate of 4%. Okay, write it down. Face rate 4%. Okay, and they're selling for 98.72. Okay. The question is, will the YTM be lower or higher than the face rate of interest? Well, I kind of gave that away in problem number 4, okay? If the face rate is 4%, that means you're going to be receiving $40 every year for one of these bonds. Then you have another way that you benefit as well. You got to buy this $1,000 bond for $98.72. That's $987.20. So that's a benefit to you as well, an economic benefit. And that means you'll make out a little bit better than the face rate of 4%. So by buying this bond at a discount, that means that let's answer the question directly. Will the YTM be lower or higher? The YTM is going to be higher, okay? If you pay a premium for this bond, the YTM would be lower, okay? So YTM is higher. You consider, when you do yield to maturity, you consider all economic ways that you benefit, not just the interest rate itself. Okay? As always, get in touch with me with any questions on any of these. Okay, friends? Okay. Number 7, the YTM is hard to calculate unless you've got a financial calculator or Excel. So financial experts and bond traders use an approximation. They use a shortcut that I've spelled out for you. So I'm asking you for the approximate YTM. On the same 4% bond, okay, that's the face rate. What else? I'm losing my place here, so let me mark my page, please. What else do we need to know? We need to know the price that we pay. The price we said was $98.72. That's $987.20. And I have to tell you how long until it matures, and that is 12 more years, whole years, until maturity, at which time it will be worth $1,000, okay? So, to find the approximate YTM, we use the formula that I provided, okay? First, we're going to do a numerator. We're going to take $40, and we're going to add, again, this is just the numerator, we're going to take the difference between the face amount of the bond and how much we pay for that bond, okay? And we are going to take that number and divide it by the amount of time until maturity, and that is 12 years, okay? That entire amount, all of those numbers combined, will be the numerator of a fraction that we're about to do, so I'm going to put a line under that as I just did, okay? The denominator is going to be found by doing the weighted average of the purchase price of the bond and the face amount of the bond at the end, okay? So I'm going to take 60% times my price, which is $987.20, okay? And I'm going to add that to a 40% weight. I'm going to do a 60-40 here. And that's going to be, of course, on the amount that we get at maturity, okay? So we're going to combine all of these aspects together. Now let's start with this one. I'm going to take 40. I'm going to add to that, okay, $1,000 minus $987.20. Okay, I'm going to divide that by 12 years. And if I math all that out, I should get, and I'm going to take this into pennies, $41.07. That's the entire amount of my numerator. My denominator is going to be 0.6 times 987.20 added to 1,000, let's do it in the same order, 0.4 times $1,000. Okay, just follow the same procedure, and you get, with pennies, $992.32. Okay, let's take that math. 4107 divided by 992.32, and I want to see the result as a percentage, so I multiply it by 100. I give you a couple of decimal places, and that is going to be my approximate YTM. My answer is 4.14%. All right, a lot of numbers there, friends, but really just plug and play. It's that easy. Okay, my last couple of problems all have to do with valuation of bonds, okay? So, number 8 says, we've got a PepsiCo 5% bond. That's the face rate. It's going to mature 12 years from now. And the current interest rates, market interest rates, we're going to consider this to be the required rate of return, are 7% on comparable bonds. Okay, that means you're sitting on a 5% bond in a 7% world. That means that your bond is going to have to sell at a discount if you want to sell it. Okay, because no one's going to pay you $1,000 for a 5% bond when they can go out and buy a 7% bond for the same price. Therefore, to sell it, you have to give them a discount, okay? So I'm expecting to see a number less than 1,000. Check your math, ladies and gentlemen, once this problem is done. If you see a number greater than 1,000, you know instinctively, intuitively, that you've done something incorrect, okay? I like to put my interest first and then my principal. I'm going to discount both of those streams of cash flows, and then I am going to add them together, and that is the price I should pay for the bond, under the principle that the value of financial security today is equal to the present value of all expected future cash flows discounted at my required rate of return. In that case, that's going to be the market rate of interest. because I and all of you agree that our required rate of return for this level of risk is 7%. We all have to agree on that. What is the interest that we get every single year? It's going to be 50 bucks. It's a 5% bond. I'm going to multiply that by, I'm going to run over to table D. Okay, it is an annuity because I get that interest every year. Don't use 5% now, friends. Okay, our answer will be on line 18, 12 years. Scroll out, 7%. 7.9427 is my my PVIFA. 7.9427. Okay, fill it in. 7.9427. Okay, and then I take my principal and I multiply that by, I go to table B. All right, 12 years, 7%. My factor is 0.4440. Okay. It gets no easier than that, ladies and gentlemen. That's how you do one of these things. $50 times 7.9427 and 1,000 times 0.444. Okay, I'm going to take all those numbers and put pennies on them. Okay, and now that I've got those discounted future cash flows, I simply add them together, and that gives me the price of my bond, which is $841.14. Okay, that's my answer. I knew that it would have to be less than 1,000, and sure enough it is. Okay, I think I'll do a proof on one of these for you after. Let's get the homework done first though. Problem number 9. Okay, problem number 9, similar. Pfizer has an 8% bond. That's the face rate. Okay, when is it going to mature? It's going to mature in 20 years. Okay, and the market interest rate are how much? 7%. Okay, same as before. Okay, so I'm just going to grab these numbers and we'll plug in the new numbers and see what happens. Okay, let's try that again. Okay, copy, come down here and paste. All right, my new and improved numbers. Okay, I've got an 8% bond, so I'm going to look up 20 years, 7%. Go to table D, 20 years, 7%. 10.594 it looks like. Okay, so I'm going to take 80 times 10.594. All right, remember now, $80 because this is an 8% bond. I'm going to get $80 every single year. Now I go over to table B and say, okay, what about the principal? That's going to be in 20 years also. If I go to 7%, my number is 0.2584. Okay. That's it. Let's do our numbers. $80 multiplied by 10.5940 and 1,000 times 0.2584. And I'm going to have to pay a premium for that bond because my bond pays 8%. And hold on one second. 8% bond, okay. Market interest rates. Okay, if I want to buy that bond, okay, and you own it, you own a bond that's paying you 8%. Best I can do is 7%, so you're going to make me pay a little bit more for your bond. That is a premium, and for that $1,000 bond, I'll have to pay $1,105.92. All right, last but not least, problem 10 says, okay, the face rate and the market rate are both the same. Okay, therefore, price of the bond must be the face amount of $1,000. We'll prove it. Let's use a bond with 10 years remaining. until maturity. Okay? This is just to prove that you should pay $1,000 prox. This is going to be an approximation for this bond. Okay? Please remember, we do always get rounding differences on these things because of the decimal expansion of the time value of money factors. Okay, so this is a 7% bond in a 7% world with 10 years to go. All right, let's go look at Table D. 7% bond, 10 years. Looks like 7.0236. All right. Okay. And now we go to Table B. Again, 7 years, 10 years, 7%. 10 years, 7%, 0.5083. Let's see what we get, okay? 70 multiplied by 7.0236 and 1,000 multiplied by 0.5083. There it is, close enough. Okay? All right, very good. Let me see, is there anything else I want to do? I think what I'll do is I'm going to try to do a fast proof for you. Let's take this bond right here. Proof of problem 8. All right. Okay, the first thing I'm going to do is I'm going to put the year. I'm going to put the amount of interest. Okay. The amount of the payment. Okay, bear with me. And the amount of the bond remaining. Okay? Then I'm going to come out here and I'm going to put the interest and I'm going to put the balance on the principal. Okay, now remember, the value of a bond is going to be equal to the present value of the stream of payments for interest and the present value of what you get at the end, okay? So, how many years do we have left on this bond? This is problem number 8. It's going to be 12 years from now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. I believe, and I'm going to actually grab the number from up top, that the present value of all of my interest payments is $397.14. Okay? I believe that the present value of my principal is $444, okay? And the present value in total will be the sum of those two numbers, okay? And now I'm going to put pennies on everything, okay? So give me one moment to do that. All right. So now what I'm going to do first of all is do an amortization table, okay? Now we know in problem 8 that every single year you're going to get 50 bucks, okay? 50. All right. Now we know that the rate on this bond at which we discounted it, and by the way, you never know if this rate's going to stay the same. That's a moving target, but we're going to assume that it does. 7%, okay? So I'm going to put 7% here. My $397.14 makes me 7%, okay? And it does so for 12 years. So my balance is always going to be the amount of interest that I earn minus how much I get. The present value will be $374.93, okay? If you carry that all the way down, you see no surprises there. We've done a table like this before. We see that at the very end, we equal 0. We have to. Okay, that's the interest portion, the stream of payments. In the meantime, the present value of the bond principal, I'm just going to make it here, friends, $444 is going to make me 7% every year, and it's going to grow. I'm not taking any payments out of that. So my 444 plus my interest means that I'll grow to 475.08 in 1 year, and that compounding will continue for the next 12 years also. Therefore, watch this. Oh, you're going to love this. All right, every single year, my bond is going to approach okay, hold on, undo that. I'm having a lot of trouble replicating lately. There we go. Watch that. Okay, right now the present value of my bond 12 years before its maturity is $841.14. The bond's value, assuming that 7% required rate of return always stays the same in the market, means my bond is going to approach its maturity value every single year. Yes, the present value of my interest stream of payments is declining, but the principal value of my bond is compounding and increasing. So when you combine those numbers, the present value of the interest and the principal, any one of those years for 12 years, okay, that present value is going to come closer and closer and closer to the maturity value of $1,000. There, ladies and gentlemen, is your proof. I hope you found that interesting. Now again, I never ask you to do proofs in my class, but it certainly helps if you try a proof or two. It certainly helps you to understand the operations of these numbers, and it really increases the faith that you have in them and in the operations that we learn here in this class in how the math works. Okay? I hope that you found that informative. That is all for now. I'm probably going to try to record and post one more lecture starting the stream of lectures on Chapter 6. Okay? Please keep up the great work, and it's an ongoing pleasure to deal with all of you. You're doing super work. Keep it going. We only have 2 more weeks. Scary, isn't it? 2 more weeks left. Okay? Enjoy your day. Happy TGIF. It is Friday, and I'll be back at you soon. Bye-bye now.